Hello, so today's topic is geometric distribution. Now let's see how you can identify a question of geometric distribution. So first of all, the variables of the question have to be discrete. That means that they have to be countable. For example, one coin toss, two coin tosses, or three coin tosses. So you see this is increasing in steps. That means that it is discrete. Alright, another condition is that the variables have to be independent. For example, I have a coin toss and I get a heads. Alright, now the next coin toss's result has no impact of the first coin toss. So that means that they are independent of each other and another condition is met. Alright, now there has to be only two groups, a heads or a tails, a 6 or a not 6, a success or a failure. These should only have two groups for it to be a geometric question. Now it ends when you get your first success. So you keep on having trials, you keep on tossing coins until you get your first success. For example, they'll say in a fair die, you keep on rolling the dice until you get a 6. So this is first success. Alright, now let's look at some general formulas. Now the first general formula is this. Now what does this represent? For example, they ask you in a question, find the probability of success in the 5th try. So you'll use this formula, PQ to the power 4, because 5 minus 1 is 4. So what you're basically doing here is you're failing the first 4 times and then you're passing the 5th time. So basically you're using this formula. Alright, now let's move at the expected value. The expected value, the mean value of a geometric progression is 1 upon p. You'll have to remember this. Okay, the mod is always 1. This is because as you keep on multiplying two less than 1 numbers, the result keeps on getting smaller. So the probability of p will always be greater, which is the success in the first attempt is always the greatest than others. So it will be the mod of this distribution. Alright, so these are some of the formulas that you'll have to remember, or you can either understand the logic I'm going to do right now. So for example, they ask you in a question, find the probability that you get success in greater than 4 attempts. So you're going to be using this formula. So you're going to use q to the power 4 and then you're going to get your answer. So similarly, you're going to use the rest of these formulas where you require them. Alright, so let's take this question as an example. In this question, they've said an ordinary fair die is thrown until a 6 is obtained. Now this happens till you get your first success, so it's a geometric. Alright, find the probability that obtaining a 6 takes more than 8 throws. Obtaining a 6 has the probability of 1 upon 6. Now greater than 8 throws, you can either use the formula q to the power n, or you can understand the logic. The logic is that you can pass either the 9th time, the 10th time, the 11th time, or the 12th time, and so on till infinity. So for you passing the 9th time, you have to fail 8 times. So simply the formula for this is q to the power 8, and in this case 5 upon 6 to the power 8, which will give you your answer. So this gives us the formula q to the power n. Okay, now as an example, let's see if the question had said greater than or equal to 8 throws. So in this case, you can pass the 8th try as well, the 8th, the 9th, the 10th, and so on. So for that to happen, you have to fail 7 times. So simply q to the power 7 and 5 upon 6 to the power 7 will give you your answer. And this gives us a formula q to the power n minus 1. So if they ask you for something that the probability of greater than n, you will use a formula q to the power n. And if they ask you the probability of something greater than equal to n, then you will say that it's q to the power n minus 1. Alright, let's move forward to another example. Alright, so in this question they say find the probability that fewer than 6 throws are required to obtain a pair of tails. So to obtain a pair of tails, the probability will be 1 upon 4, the probability of success, and it says fewer than 6 throws. Now, you can either add all of the probabilities from 1 to 5, the probability of 1, the probability of 2, and so on till the probability of 5, because it's less than 6. Or there's a shortcut. The shortcut is that 1 minus the probability of something greater than equal to 6. You can either do this. and the probability of something greater than equal to 6 was q to the power n minus 1. So in this case 5. So 1 minus q in this case is 3 upon 4 to the power 5. So basically this gives us the formula. If something is less, the probability of less than n will be equals to 1 minus q to the power n minus 1. Alright, now as an example, let's see if the question had said find the probability that less than or equal to 6 throws are required for success. So we could again add all the probabilities of 1 till 6 this time because it's equal to 6, or we could use the formula 1 minus the probability of x greater than 6, and the probability of something greater than 6 was q to the power n. So in this case q to the power 6, which will give you your answer, and that gives us the formula 1 minus q to the power n in this case. So if they ask you the probability of something less than equals to n, you will write the formula this and use it in the question. Alright, so one last thing I'm going to do is that there's a question that why didn't we add the probability of 0? So there is no probability of 0 in geometric because you can't have success in the 0th attempt. Alright, so that was all of geometric distribution. Thank you for watching. Goodbye.